2009 for 1 mark. So this is a rotor shaft of a large electric motor supported between the short bearings. So here they said this is a short bearing, and deflection has given deflection also. Deflection or delta equal to 1.8 mm, and at the middle of the rotor. So this is at the middle of the rotor, and we here this this rotor is perfectly balanced. If it is not perfectly balanced, then it will lead to the willing of the speed, willing of the shaft. And what is the critical speed of the shaft? Critical speed is nothing but the omega natural frequency, because the critical speed is the speed at which the amplitude of vibration is very high. So that actually happens when the omega equal to omega n, that is at the resonance point. So whenever they say critical speed, then we need to find out the omega n, that is a square root of g by delta. So this is simply substitution, 9.8 by 1.8 into, this is given in the mm, so we need to convert into the meters. So 10 power minus 3. Why? Because the g value is in the SI units, that is meter per second square. G value in the meter per second square. So the value is 73.786. What is this? Radian per second. But here they ask about the critical speed in RPM. That means number of revolution per minute. So we know omega n equal to, omega n equal to 2 pi n. If n is in the RPM, then we need to divide with the 60. So from this one, n equal to, or if you forget to divide with the 60, even in that case we can get omega n by 2 pi. So in that case we will get a number of revolution per second. So if you want to get the number of revolution in minutes, then we need to multiply here with the 60. So from this we will get approximately 70.6. This is approximately 705. Answer is B. The rotor mass is a rotor mass is k, 10 kg is given. Rotor displacement in a middle of a massless shaft, middle of the massless shaft. This is like a point load at the middle of the shaft, and diameter also given. Diameter of the shaft. This is the diameter of the shaft, d. Diameter also given, and then length of the shaft also given. Length of the shaft, and here he also given that it's a shaft is assumed like a simply supported, and remaining this e value also given. So what is the critical speed? Here again the critical speed omega n we need to find out. Omega n equal to again g by delta, and g by delta, here we need to find out the g by delta, and this is a simply supported beam having a mid load. So what is the deflection in this case? So deflection in this case, delta equal to WL cube by 48 EI. So W has given, what is the W? That is in Newton. So 10 into 9.8 mg. This is a mg. So 10 into 9.8. This is a 98 Newton, and the length also given, that is a 0.5 meters, and E also given. We need to find out the I, and the shaft diameter, when they said diameter, this is a nothing but a circular shaft. So this is the our neutral axis, and we need to find out the I about this neutral axis for this circular shaft. So what is the formula for I here? I equal to pi by 64 d power 4. So if I calculate this value, pi by 64 into 30 into 10 power minus 4 whole power 4. So this value is 3.976 into 10 power minus 4 minus 8. What is this? This is a meter power 4, because here we converted diameter into meters. So this is in a meter power 4. So if I substitute this value here, what is the delta value? Delta value equal to 98 into 0.5 cube divided by 48 into E. E is a Pascal. Pascal is Newton per meter square. So that is also in SI units, proper units. So I directly substitute 2.1 into 10 power 11 into I. I value 3.976 into 10 power minus 8. This is 8. So delta value is 1.91 into 10 power minus 6 meters. So we got delta, then omega n here. Omega n equal to 9.8 into delta, that is 1.91 into 10 power minus 6. Then we will get 566.237. This is a radian per second. But now we need to find out the critical speed in terms of hertz. Then we need to find out the frequency. So what is the frequency? Omega n equal to 2 pi n or 2 pi f. So here f equal to this omega n. So 566 by 2 pi. So then we will get a 90.11 hertz. So answer is B.